Hello, in this video we shall talk about the introduction to Matlab. So we will just do a short introduction to Matlab and then we can say how to apply Matlab in solving some problems. Now Matlab is a mathematical and graphical software package with numerical, graphical and programming capabilities. It includes an integrated development environment, as well as both procedural and what we call the object-oriented programming constructs. It has many built-in functions to perform operations. And there are also toolboxes that can be added to augment these functions. Now, when you double-click the Matlab icon on the desktop of your computer, a window will open, and in this window, the main part will be what we call the command window. We shall have three windows, but the main one will be the command window, which is this white space here, with the double subscript sign, which is the command prompt for Matlab. Then there is another small window here, which is the current folder, the folder where the current file is stored. And then the workspace. The workspace is used to basically store the variables that are being used by the Matlab. So we have the main window here, which is the command window with the prompt, Matlab prompt, the double script sign. Sorry, not the double, the double greater than sign, which is the Matlab prompt. So in this one, you can type 3 plus 4, and we know 3 plus 4 is 7. So when you press enter, Matlab will compute the value of 3 plus 4, which is 7. So the command window will act like a big calculator where you can perform your operations there. You can add numbers, you can multiply, you can find the cosine or the sines of angles. You can do almost any kind of mathematical operation on the command window. So if you type cosine of 1.3, for example, and you press enter, you get the value 0.2675. This is the cosine of 1.3 radians. So you'll notice that here we had the answer is equals to 7. Here we have answer is equals to 2.67. So answer is a kind of variable which is generated when you just press enter there. So if I type ANS and press enter, you'll get the value. But if I type 4 plus 5 and hit enter, I'll get the answer is 9. So now if I type the answer and hit enter, I'll get the answer is 9. So this one takes the recent value. I can press the arrows. There are some arrows in the keyboard, and if you press the arrow that points up, you get the list of the operations that you have done. Then you can pick the one you want. I pick like cosine of 1.3 and hit enter. Again, I get the cosine of 1.3 radians. But sometimes I may want the cosine of angles in degrees, so we use the cos d. This should give you cosine of angles in degrees. So that now, if I type 30, this will now be 30 degrees. Cosine of 30 degrees, which is 0.866. And so on. So in this case, when you type an operation there and press enter, you get the solution. Matlab will just compute the solution to that. Now we have mentioned that the workspace stores the variables. So here we have only one variable, a and s, which is 0.866. But this one will keep value. If I type sine b of 45, we say sine of 45 degrees, 0.707, and you can see the value here has changed, 0.717071, which is sine of 45 degrees. So, but we may want to use variables. We may want our variables to fix some values to some variables. Like we want to set a variable x whose value is 1, or a variable y whose value is 2. Now, to store a variable in Matlab, or to store a value in a Matlab session, we use a variable. So to create a variable, we use what we call an assignment statement. The format of the assignment statement, we write the variable name, then we use the equal sign, then the variable value. So in this case, the equal sign will be called the assignment operator. So for example, I may want to have a variable x whose value is 5. So I'll write x is equals to 5, meaning that x is the name of the variable. And then we have the equal sign here is called the assignment operator. And then we have 5. So when I press enter, what will happen is that the Matlab will create a variable called x and store a value 5 in it. So when I press enter, you say in the workspace there is x and the value is 5. The variable name is x. The value of the variable is 5. So we also have x is equals to 5. I can create another variable called y and store a value 7 and press enter. I can create a value z and store a value 9 and press enter. So that I have now 3 variables, x, y, and z. I also have the variable a and s, which is the answer to the previous operation that we carried out. So in this case, the variable name is always to the left, like x is equals to 5. So if I try to write 5 is equals to x, or 5 is equals to w, Matlab will not create a variable called w and store 5. It will tell me that there is an error. So when I hit enter, then there will be an error message. The expression to the left of the equal sign is not a valid target for the assignment. So you say this one replies with an error. So, but I can write w is equals to x if I want w to have the same value as x. And w will now be having a value 5, which is the same as x. Sometimes I may want to have a variable called x1 and store a value 2. Matlab will accept that, but it cannot accept 1x. I cannot call a variable 1x. The variable name cannot start with a digit. It can only start with a letter. So if I type 1x is equals to 6, Matlab will tell me that there is an error. To reply with an error message, the error, unexpected Matlab expression. So sometimes you see when we type, for example, x1 is equals to 3, and press enter, you see that Matlab will create a variable x1 and store a value 3 in it, and then reply with x1 is equals to 3. I may not want this output x1 is equals to 3 because it is taking some space for nothing. So I may want to write, for example, x2 is equals to 9, and I don't want Matlab to display the output. So I add the semicolon. Then when I press enter, Matlab will still create a variable called x2 and store a value 9 in it, but will not display anything on the command window. You see there is no output in the command window. There is only x2 is equals to 9, which I had typed, but there is no output. But we have the value x2 stored in it. If I type x2 and press enter, I say x2 is there. It has already been created, and a value is stored in it. Now, once we create these variables, we may want to know which variables do we have in our workspace. Of course, we can see them here. I suppose we want to display some information about them. We type who will tell us which variables we have. So we have how many variables? You say your variables are ANF, W, X, X1, X2, Y, and Z. But we may want to know more information about these variables, so we type whose. Will display more information about each of these variables. So we see the name of the variable, the size, the bytes used, the class, and so on. We have a lot of information about our variables now. So basically, this what we call this is how we do our variables in Matlab, and we have said when we type a statement such as say z is equals to 5, this will create a variable called z and store a value 5 in it. And this value is saved in a part of the computer memory that we are calling the workspace. Here, you can see z is equals to 5. A workspace is basically a collection of all variables and array that can be used by Matlab when a particular command is executing. So the list of all variables that Matlab can use. All commands existed in the command window share a common workspace. It's important to note that all the commands that we are going to perform on this command window, they share the common workspace. This means that the variables that we have stored here in our workspace can be used in the command window. For example, we write x plus y. We know that our x is 5 and y is 7, so we should expect a value of 12. 5 plus 7, which is 12, and that's what we get. We can write x1 times x2. So by multiplication, we use the star to multiply variables, multiply quantities in Matlab. You see this is x1 is 3, x2 is 9 from our workspace here. So when we write this, we should expect a value of 27, and we have it there. We can even create another variable and call it g, for example, and say g is equals to y plus z. And we know y is 7, z is 5. Y plus z, we will expect a value of 12. So g is expected to have a value of 12. When I press enter, G is 12. I can say G in the workspace now is equals to 12. So now, I may want to clear the command window that all this information displayed here. Maybe I don't want to see it. I type CLC. So I clear everything. My command window is now clear. It has nothing on it. But the variables are still there in the workspace. So if I want to write G times 2, I still get the answer is 24. If I want to write X plus Y, I'll still get the answer. And so now, suppose I want to clear a variable. I don't need them anymore. Or I want to clear one variable. I don't need x1. So I write clear x1. I want to delete this. I don't want a variable called x1. I write clear x1, press enter, and x1 is removed from my workspace. So that if I now type x1, Matlab will tell me that that variable does not exist. And define function of variable x1. The variable basically does not exist. Suppose I don't want any of these variables. I write clear all. This one will clear all the variables from my workspace. So when I press enter, we expect that the workspace will be cleared and there will be nothing displayed there. Everything is removed from the workspace. And if I now want to create more variables, I'll create new variables. So I write, for example, y is equals to -3 or -2. And I use a semicolon to suppress the output. And the variable y is created with a value -2. Sometimes we want what we call the absolute value. The absolute value is usually obtained by squaring the number and then taking the square root. Then you take only the positive root. So the absolute value of -2 would be obtained by first squaring -2 to get +4. Then take the square root of +4, which is +2. Basically, for the absolute value, if the value is negative, you just ignore the sign. Basically, it's just that. In Matlab, we can write the variable z. Maybe I want a variable z which is an absolute value of y. So I use the command abs y. The absolute value of y, I should expect that z will take a value of +2. So when I press enter, z is +2. So now if I write y plus z, this is small y plus z, I should get 0. Notice that I have made a mistake when typing error. Y plus z. This one is a typing error because I wanted to use small y. But for I made an error and typed capital. If I press enter, this will yield and will give an error because capital Y is not defined. So you say undefined function of variable. And Matlab is predicting probably I wanted to write small y, which is exactly what I wanted. So if it is suggesting, did you mean y plus z? And yes, that is what I meant. It was, I did a typing error. So I press enter and get the answer is 0. Now, so you realize that for Matlab is case sensitive. So capital Y and small y are two different things. So I can create a variable called capital Y and assign it a value of 5. So it will not be a very good practice to create variables in both capital and small letters, because now that one will create might be a problem. If you mean to type small y plus small x but small z, which the answer is 0 here, but you type y plus small z now, there will be no error message because capital Y is there. So you end up with a wrong solution, the solution that you do not intend to have, because you have created variables in both capital and small. It's important to use small letters when creating variables. So we shall use small letters. And where for some reason we feel that we want to use capital, then we shall not use the small letter. So we will not create variables small x and another variable capital X. If we decide to use capital, just use capital throughout. If you decide to use small letters, use small letters throughout to avoid the case where you would have such errors. You see now, I can clear Y so that when I type by mistake Y plus Z, Matlab will tell me that I've made an error, that I've used a variable which is not defined. Just that will minimize the kind of errors that you are likely to have in your program. Now, the other thing we may want to have is the comments. Comments in a program are generic sentences, mostly written in a program to explain what the program is supposed to do, or what a piece of code in a program is supposed to do. More specifically, comments are written by the programmer to help him or her remember what a given line of code is supposed to do, or to explain to other programmers who may want to use the code that you have generated. These commands will tell them what that line of code is supposed to do. The comments are therefore have nothing to do with the program. They are only meant to explain to the programmer, which is the person, what the line of code is supposed to do. So, I create a comment, a variable called x. X has a value 5. Sorry, x is equals to 5. X has a value 5. I create another variable w, which is equals to 4. Now I have those two variables, x and w. And now I want to use a comment. Comments normally begin with they begin with the % sign. So anything I type here, it's even written in green, it's a comment. It will not be executed. Matlab will not execute this. To just ignore that. To not do anything. So if I type a variable called t, and like t is equals to x plus w, for example, I can put a comment here and say t is the sum, is a sum of x and w. This part here is basically telling me what t is, or any other person who would be using this is telling him that t is obtained as basically a sum of two numbers x and w. Matlab will not execute this. It will only execute t. It is for the the statement here, the Matlab has just added x plus w, 5 plus 4 to get 9, t is 9. The other statement, this one, is a comment meant for the person looking at this, telling him that t is supposed to be a sum of two numbers, x and w. So basically that is what a comment is. It's a generic statement. It's a generic sentence. And the purpose of the comment is to explain to the programmer what a specified line of code is supposed to do. Now, in Matlab, there are three types of comments. We have the single line comment, like the one we have here. Starts with the percent sign, and then everything that you write is taken to be comment. We have a block comment that starts with the percent sign, and then followed by the braces, and then we have the percent sign. This may span a number of lines, so you may write something here. This is a comment, and you may write several lines of this, but everything will be a comment. You start with the percent, followed by the opening brace, and then the percent and the closing brace, so that in a statement that you write here, it may span over several lines, and this will be a comment. So, single lines comments, as we have said, they are usually drafted to explain a single line of code, what a single line of code is doing, and they start with the percent sign, then you type whatever follows. Then there is the block comment, which start with the percent followed by the brace, the curly bracket, and then you type the comment in between, and then the percent and the closing brace. That's called a multi-line comment. Then there is what we call the comments in a statement that span multiple lines. This is usually a comment spanning in a statement. Maybe I can show you how the comments will look like. They may not be typed well in command reader. Let's see. So we have the comments. The single line comment, for example, we write percent, single line comment. Anything that follows the percentage sign will be a comment. For example, we type display below is a comment using the percent. Then we type the percent, this is a comment. This line will not be displayed when you run the code. You will only get below is a comment using the percent. Then the block comment, we start with the percent sign, then the curly bracket, then you have the percent sign and the curly bracket. Anything you write in between here will be considered to be a comment, something like this. Then you have the comments spanning multiple lines, commenting part of a statement that span multiple lines using the ellipses, the dot, dot, dot. So you write, for example, x is equals to Matlab is a programming language, then you type all that. There is this part here. You write the dots, then you write that, then you add with the dots here. This line will be comment to not be executed. So when you run this one, Matlab is a programming language. Then it will skip this part here, which is in green, and it is goes to the last statement here. It is a user friendly. It's user friendly, and that is what will appear. Now, so we shall see that when we want to write what we call the script files, you may not want to run that one in a command window. So now we want to look at matrices. Matrices. So with Matlab is short for matrix laboratory. So anything that is there is assumed to be a matrix. So when you write any variable, it's assumed to be a matrix. Now the simplest matrix is a 1-by-1 matrix. So when you type A is equals to 3, this one is assumed to be a matrix. My Matlab will take this one to be a matrix, which is a 1-by-1 matrix. So say when you type O, you can see your variables. Let me type those. And A is size 1-by-1. It's a matrix. It's a 1-by-1 matrix. So this one is anything that you type in Matlab is assumed to be a matrix. So if I type B is equals to, then I put the square bracket, then I type 2, 3, then I close. This will be taken to be a 1-by-2 matrix. So if I type whose, I can say B is a 1-by-2. 1-by-2 here. It's a 1-by-2 matrix. I can type C is equals to, I could have used the size of B. If I just want to know the size of B, answer is 1, 2, 1. This means 1-by-2 dimension. I can type C is equals to 2, 4. Then I use the semicolon. I type -1, 5. Then I close the bracket. Notice that we are using the square bracket. This will create a 2-by-2 matrix with the elements 2, 4 in the first row and -1, 5 in the second row. So the semicolons here is used to add the row. So you see the matrix 2, 4, 1, -1, 5. If I type the size and then I say, notice that this one is capital. I press enter, I'll get C is a 2 by 2 matrix. C is a 2 by 2 matrix. If I type whose, I'll say that C is a 2 by 2 matrix. B was a 1 by 2, and A is 1 by 1. So that's how we create matrices. So matrices can be of any dimension here. So I may want to write B is equals to 2. And here when I create a matrix, I can use comma or space. 2, 4, 6, 8. Then if that is the head of my first row, I put the colon. The second row, 3, 0, minus 2, 5. Then that's the head of the second row. I put the semicolon. I put the next row 1, 6, 0, or say minus 4, minus 3, 7. If that is the head of the third row. If there are no fourth row, I will put now the closed bracket, the square bracket. I press. I may not want to see the output, so I put the semicolon to suppress the output. I press enter. B is created here, and it's a 3 by 4. You can see from the workspace, B is a 3 by 4 matrix. So if I type B, I can say B is a 3 by 4. Now remember, the elements of a matrix starts with A11, or in this case B11, B22, B23. So B11 would be the element 2, B22 would be 4, B33, not 22. It is B11, B12, B13, B14. So B14 is 8. So I can type B, then brackets. This is a normal bracket, 1, 4. This is the element B14, the one we write B with the subscript 14. If I press enter, I'll get the value is 8, the value here. If in the second row I want to get the element minus 2, this is in the second row, the third column. So that is B2, 3. B2, 3. I should expect a value of minus 2. If I want the value such as this, such as 7 here, this I see is in the third row, fourth column. So I'll type B, 3, 4. I should get the value 7. Sometimes I want to extract the entire row, like the second row. Let me have the B here again. I want the entire second row. So if I type B, 2 is the second row, I put a comma. Then I put the semicolon, like that, meaning that not the semicolon, but a colon, a full colon. I want the entire row. And maybe I want to call this this B2. So I want to call this value B2. B2 is equals to that. The elements, the second row. The second row. I press enter. I say, so now B2 is the element. Has the element 3, 0, minus 2, 5. So these are the elements of the second row. If I want to get to the third column, for example, which I may want to call column 3. I write B. Sorry, I should start with B. Then I want the column. So all rows, the elements in all rows, column 3. So column 3, all rows, meaning that I put the full column, because that I want to get the elements, all the elements in that column, in that column. I press enter, I get 6 minus 2 minus 3, which are the elements in the large column. So basically, these are some of things you can do when you have a matrix. So we can display some of these elements. We can generate a vector called A, for example. A is equals to a row vector. If I want the numbers 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will give me a vector, a row vector with 10 elements, numbers 1 to 10. And so we have them there. But this is not the best way. I can write A, or let me call it B now. B is equals to the numbers 1 to 10. I just use a colon. 1 is the first number, and 10 is the last one. So this will generate a sequence of numbers from 1 to 10. You see, the best thing with this is that while I can type the numbers as I have typed here 1 to 10, if I want numbers from 1 to 100, it will be a lot of work typing all this. But I can type C is equals to 1 to 1 to 50, for example. 1 to 50. I'll generate numbers 1 to 50. C will now have all those numbers up to 50. It would have been a lot of work typing all those numbers. I may not want C to have all these numbers from 1 to 50, but I may want maybe the odd numbers. 1, then I skip 2. So I go to 3, and maybe up to 50. So in this case, this will be adding 2. 1, then 1 plus 2 is 3, so it outputs 3. Then 3 plus 2 is 5, it outputs 5, and so on, up to 50. But 50 will not be included in this case, so it will go up to 49. Here let's say 1, 3, 5, 7. So this generates a sequence, an arithmetic sequence, with the first term 1, the common difference is 2, and the last term is 50. But because 50 cannot be generated by this, so it goes up to 49. Because 49 plus 2 will give us 51 to exit the last value that I've indicated here. So it goes to 50. 49 in this case. So that generates a series of integers. They don't have to be integers. So I can put say A is equals to 1, then 0.5, then the last number I may want 5. So this one will start from 1, then to 1.5, 2, 2.5, and so on. So 1, 1.5, 2, 2.5, 3, 3.5, is adding 0.5. So I can generate any kind of sequence that I want. Now, if I have A, for example, is equals to 2, 3, 12, this will be expected to give me 2, then 5, then 7, then 10. So 10 plus 3 is 13, so let me put the last number as 13. So 2, 5, oh, well, not lighter. Let me go back and put 14. 14. So 2 plus 3 is 5, but 5 plus 3 is 8, 8 plus 3 is 11, then 11 plus 3 is 14. So if I put sum A, this will give me the sum of this series. 2 plus 5 plus 8 plus 11 plus 14. Say 2 plus 5 plus 8 plus 11 plus 14 is 40. So I just write the sum of this sequence. I can also want to multiply. So I write plot, the product of the elements of A. So that should give us the 2 times 5 times 8 times 11 times 14. Maybe we should have used a smaller series. Let's say we have another series. B is equals to 2, 3, 8. These are only 3 numbers. Here I want to use 3, so that we have 2, 5, 8. So when I write sum of B, this is the sum of 2 plus 5 plus 8, which is 15. When I write the product of B, this is the product. 2 times 5 times 8. This is expected to be 2 times 5 is 10 times 8 is 80. And you get the answer there as 8. Sometimes we may want to delete some elements in a vector or in a matrix. Like in a matrix, in this vector B, we have B11 is 2, B12 is 5, B13 is 8. But this being a 1 by 3, we can as well say just let me reproduce it here. I can just say B1 should be 2, and B2 should be the next element, which is 5, and B3 should be the last element there, which is 8. Now the idea here is that this are 1 by 3. So when we say B11, B12, B13, the first subscript, in the subscript, the first item just talked about the row, but there is only one row here. So we can as well ignore it. So we have B is that. So if I want to remove the element 8, for example, this is the element B3. I will type B3 is equals to, then I put it as empty. Or I want to replace with maybe 10. I'll put 10. I'll put 10 there. When I press enter, The element 8 will be replaced by 10. Let's enter. So now B is 2, 5, 10. If I want to just delete this element, I'll just leave it blank like that. B3 is empty. So when I press enter, B has now 2, 5. There is no other element. So the element has been removed. Now I want to know the dimension of the matrix, so I type size of the matrix B. This will tell me that B is 1 by 2. It's a 1 by 2 matrix. If I want to go back to some matrix here. We had some matrix like matrix B capital. Let's go back to this matrix. And if we type size of B, this will give us that this one is a 3 by 4 matrix. But suppose I type size of B, comma 1. This I'm asking, how many rows do I have in the matrix B? And we say that there are 3. If I type 2 here, I'm asking how many columns do we have in this matrix? And I can count 1, 2, 3, 4. So how many columns? There are 4. So I may want to know only the columns or only the rows. And there are many operations you can perform with this matrix. You can have matrix multiplication. So if I have the matrix A, let me clear all variables here so that I clear my workspace. So I have the matrix A, which is equals to 2, sorry, 2, 3, semicolon, 4, 5. This is a 2 by 2 matrix. You can see it. And then I have B. B is another 2 by 2. 3, 5, semicolon. Then 1, 0. This is another 2 by 2. I multiply A times B. I use the star A times B. This is a matrix multiplication. Multiplying the matrix A by matrix B. Sometimes I don't want to do that. I want to just multiply the elements of the matrix A with those of B. So I will not use that. But I'll use what we call the dot product, like that. The dot product. A dot times B. So this should multiply 2 by 3, 3 by 5, 4 by 1, 5 by 0, and give me the output. You see now we have 2 times 3 is 6, then 3 by 5 is 15. And you can see those are the elements there. The next one is 4 times 1, which is 4, 5 times 0, which is 0. I can see what the elements we have. So here we are multiplying just the elements of A with the corresponding elements of B. This is not matrix multiplication. It's just multiply the corresponding elements. If we write A plus B, this is the normal matrix addition. If we write A minus B, this is the normal matrix addition. You can get the inverse of A. So we write the inverse of A. I want to give it a name. I'll call it M. M is equals to the inverse of A. I and V, and I put here M. I can put a comment to explain. So we said the comments are used to explain what a line of code is doing. So I can put a comment that M is the inverse of the matrix A. So M is the inverse of the matrix A. When I hit enter, the comment part will not be, matrix will not do anything to the command part, only the computing the inverse, and I have the inverse. So suppose now I multiply M by the matrix A, the normal matrix multiplication. So I get an identity matrix, because a matrix A multiplied by its inverse will give us an identity matrix. So basically these are some of the operation, all the kind of operations that we do with matrices. We can do them in Matlab. So basically these are some of the operations with Matlab. Matlab again is a short for matrix laboratory. So any variable you create is considered to be a matrix. Matrix can be a 1 by 1, or 1 by 2, 2 by 2, or any dimension. There are no limitations here. You can create a matrix of very high dimensions. So basically these are some of the important operations you can do with matrices in Matlab. We shall look at the logical operations. We shall look at those next.